Hello, Earth and Space Science students. So these are going to be the directions for the Comparing Continental and Oceanic Crust. So you're going to find that assignment on Google Classroom. This is what it looks like. I had to do some editing today. You can see a half hour ago because one of the websites was broken. So what you're going to do in the first one, you're learning about something called paleomagnetism. And I can kind of give you the quick rundown. Paleomagnetism is in the different parts of the crust within those rocks. Some of them are able to be magnetized, so impacted by a magnet, while some aren't. And the Earth, there's a pattern in terms of the magnetic field, and I don't know how often it flips, but it'll flip like on a somewhat set schedule. The video will talk more about it. And so what we can do is we can kind of go back through different rock layers. In this case, it's through the seafloor, and you can kind of almost date it using when it flipped, because the rocks within that row of rock. I'm saying this wrong. The rocks in the ocean floor for that strip will be magnetized in a certain direction based on the magnetic field, and then the rocks maybe next to it might be going a different direction if the field had flipped. And so we can kind of go back to the beginning to kind of use it to help date the ocean floor. The video will explain it probably a little bit better than I did, and it's not actually 10 minutes; it's 8 minutes and whatever. So don't get scared by that. This is the one I had to change, and so what we're actually reading about is how this paleomagnetism ties in with seafloor spreading. It was like an interactive that I thought was better. But I don't hate this. This actually, I think, explains it really well. So you're really looking at, it's this kind of paragraph here, which I like, it's bullet pointed, and then this little explanation down here. What I really like is this graphic. So I'm going to zoom. Can I zoom in? I'm going to zoom in. I'm going to do it. So this graphic here is showing kind of what that paleomagnetism on the seafloor looks like. So on a mid-ocean ridge where we have new seafloor being created, the rock that is going to then become part of the ocean floor from that seafloor spreading is going to have a certain magnetic direction, what they might call polarity. But sometimes it flips. And so sometimes you see like those white bands here. That's when the magnetic field may have flipped. It hasn't happened in our lifetime because our North Pole is in the north. I lied. Ours is in the south. This is all confusing to me. I should probably read this whole thing, but it looks weird, doesn't it? Oh, because the magnetic North Pole is up here. Okay. Anyway, so depending on that, the rocks will be aligned a different way. I still explained it right. And so we can kind of use that to trace back how old the different ocean floors are from being fairly new in the middle versus older as we get farther out. That's really the whole gist of it. So don't go too crazy on that one. Later on, you're going to be looking at maps of both the ocean floor versus continental. So what you're going to see on the ocean floor, the red is the youngest rock. And so on these mid-ocean ridges where new seafloor is being created, it's also the youngest. As I go away from those ridges towards, say, the blue, that's the older rock. And so all of these areas that are usually blue or maybe even green, those are going to be subduction zones. That's where the seafloor is being destroyed. It's going underneath, usually continental crust here, because nothing new is being created. Only the red stuff is making new stuff. And so that's kind of what we're getting at here. You'll follow it up with a map of continental versus oceanic. Oh no, that's broken. I'll find a map, because really the big thing is that the continental is super old, because that doesn't really get destroyed as easily as, say, the oceanic does, because it's less dense. Here you're looking at the thickness of the crust. So the higher it is, the bigger the number, the thicker the crust is. And it should kind of make sense. Continental crust is thicker than oceanic. That's why the continental crust is higher than the oceanic. It's above it. It's taller. And then this is just another little thing about seismic waves as review. And then exit ticket. I will fix that link though, because all you really need is an image, a map. Actually, you might not even need it, but that's what I want you to do. Hopefully that works. Have a great day. Bye-bye.